Imagine you are holding a flashlight in the deepest, darkest canyon on Earth. You flick the switch, expecting a beam of light to cut through the night. But instead, the light doesn't travel up. It bends. It curls back toward the ground like a dying vine, falling into the shadows as if the darkness itself had hands. You aren't in a canyon anymore. You are standing on the edge of the most misunderstood object in the cosmos. We call them holes, but that name is the greatest scientific misnomer in history. A black hole isn't an empty pit, and it isn't a tunnel to another land. It is something far more terrifying. It is the ultimate destination of matter itself. Welcome to Deep Science Explained. Today, we are dismantling the most famous icon of the mystery of the universe. We've been conditioned by sci-fi movies to see black holes as cosmic vacuum cleaners or swirling drains in the bathtub of space-time. But as we peel back the layers of general relativity and quantum mechanics, a startling paradox emerges. If you were to actually fall into one, you wouldn't fall down a hole. You would be crushed into a sphere of infinite density that occupies zero volume. It isn't a hole in space. It is space compressed until it breaks. How can something be both a physical object and a mathematical ghost? And why is the truth about their surface the key to understanding why reality itself might be a hologram? Let's start with the name. The term black hole was popularized in the 1960s, but it's a linguistic trap. In reality, these are frozen stars or gravitational singularities. To understand why they aren't holes, we have to look at how they are born. Imagine a star 20 times the size of our sun. For millions of years, it lives in a state of violent balance. Gravity wants to crush the star inward, while the nuclear fire in its core pushes outward. But eventually, the fuel runs out. The fire dies. In a fraction of a second, gravity wins. The star collapses. But it doesn't just get smaller. It collapses with such ferocity that it punches through the floor of reality. We often visualize space-time as a flat trampoline. If you put a bowling ball on it, it creates a dip. That's gravity. A black hole is often shown as a bottomless well in that trampoline. But space isn't a 2D sheet. It's a 3D fabric that surrounds us in every direction. A black hole isn't a hole down into something. It is a sphere. If you approached one from any angle, top, bottom, left, or right, it would look like a perfect pitch black orb. It is a three-dimensional shadow. It is an event horizon, a border where the exit velocity required to escape is greater than the speed of light. On Mars, you need a rocket to leave. On a black hole, not even a photon, the fastest thing in existence, is fast enough to get out. But here's where it gets crazy. We have to talk about what lies at the very center, the singularity. In the traditional hole model, we imagine a point at the bottom of a pit. But in reality, the singularity is a region where the curvature of space-time becomes infinite. This is the ultimate no-man's land of physics. Here, our current understanding of the mystery of the universe simply stops working. General relativity says the density becomes infinite. Quantum mechanics says that's impossible. This is the front line of modern science, a place where our best theories go to war. If a black hole were a hole, it would lead somewhere, but a singularity is more like a dead end. It is a place where the dimensions of length, width, and height are crushed into a single point. Imagine taking the entire mass of the Earth and squeezing it until it fits inside a marble. Now, squeeze that marble until it is the size of an atom.
Now, keep going until the size is zero, but the mass remains. That is not a hole. That is a knot in the very fabric of existence. Deep Science Explained isn't just about the physics. It's about the feeling of the infinite.
Imagine you are an astronaut drifting toward a black hole. From your perspective, nothing feels like a hole. You are simply drifting through space. But as you cross that invisible line, the event horizon, the geometry of the universe flips. Inside a black hole, space and time swap roles. Outside, you can choose to move left or right, but you cannot stop yourself from moving toward tomorrow. Inside, you can no longer move toward tomorrow. The singularity, the center, is no longer a place in space. It is a point in your future. You aren't falling into a center. You are falling toward a moment in time that is unavoidable. To turn away from the center would be as impossible as you turning around right now and walking into yesterday. Did you know that if you watched a friend fall into a black hole from a distance, you would never actually see them fall in? Because of gravitational time dilation, as they get closer to the event horizon, their time slows down relative to yours. You would see them turn red, fade, and eventually freeze in place, stuck forever like a fly in amber on the edge of the abyss. They would appear to be smeared across the surface of the hole. But from their perspective, they would cross the horizon in a heartbeat, seeing the entire future of the universe flash before their eyes in a single second as they are pulled toward the singularity. This is the information paradox, a central conflict in science explained by modern physics. If matter is destroyed inside, where does the information go? Nature usually doesn't allow information to be deleted. If you burn a book, you could technically reconstruct the text if you tracked every molecule of smoke and ash. But a black hole? It seems to erase the book entirely. This brings us to the big discovery, the holographic principle. Some of the greatest minds in quantum mechanics suggest that a black hole isn't a 3D object at all. Instead, all the information about what fell into the black hole is stored on its 2D surface, the event horizon. It's like a cosmic hard drive. When you fall in, your 3D body is shredded, but your data is saved on the surface. And if a black hole stores information on its surface, some physicists believe the entire universe might work the same way. What if everything you see, touch, and love is just a 3D projection of information encoded on a distant 2D boundary at the edge of space? As the physicist John Archibald Wheeler once said, "It from bit." Every particle, every field of force, even the space-time continuum itself, derives its function, its meaning, its very existence from the apparatus elicited answers to yes or no questions, binary choices, bits. In this light, a black hole isn't a hole or a drain. It is a library. It is the most efficient storage device in the universe. It is a place where the laws of nature are stripped of their disguises. Deep Science Explained shows us that by studying these dark titans, we aren't just looking at the death of stars, we are looking at the source code of reality. We are looking at Planck lengths, the smallest possible units of space, and discovering that space itself might be made of discrete pixels of information. If the universe is a computer, the black hole is the processor, where the data is most densely packed. It is the ultimate limit of how much stuff can exist in one place before the system crashes. But there is another reason why hole is the wrong word. Hawking radiation. For decades, we thought black holes were eternal traps, but Stephen Hawking proved that they actually leak through a process involving virtual particles at the edge of the event horizon. Black holes slowly lose mass and radiate energy back into space. Over trillions of years, a black hole will actually evaporate. It doesn't stay a hole. It eventually dissolves back into the universe. It is a temporary storage unit, a pause in the flow of cosmic energy. If they were truly holes in the fabric of space, that energy would be gone forever. Instead, it's just being held in a gravitational vault, waiting to be released back into the vacuum of space as heat. What if we've been looking at black holes the wrong way because our brains aren't built to see 4D reality? We see a hole because we see the absence of light. But a black hole is actually the most full thing in existence.
It is a region of space packed so tightly with matter that it has become a knot in the universe. If you could see the mass without the darkness, it would be the brightest, most solid object imaginable. It is the ultimate density.
So, why do we keep calling them holes? Perhaps because it reflects our own fear of the unknown. A hole is something you fall into and never return from. But as we've seen today, a black hole is a bridge between the world we know and the quantum realm we are still trying to map. It is a place where the mystery of the universe becomes a tangible physical wall. In the end, we have to ask, if black holes aren't holes, what else have we misnamed? If a black hole is a sphere of information, is the void of space actually empty? Or is it a sea of data we haven't learned to read? Maybe reality isn't a place we live in, but a story being told on the surface of something much larger. What if we are the information and the whole is the only thing that's actually real?
What if the singularity isn't the end of a journey, but the point where our understanding of the mystery of the universe must be reborn? Every time we think we found a hole in the universe, we discover it's actually a mountain of information we haven't yet learned to climb.
I'm your host, and this has been Deep Science Explained. If this deep dive into the cosmic abyss changed how you see the night sky, hit the like button and subscribe. We are just beginning to scratch the dark.
In our next episode, we'll uncover something even stranger: white holes, the theoretical birth of matter that might be the exit ramp for everything a black hole swallows.